Awesome. For this activity, it's a division box task. So what I'd like you to do is choose one of those digits that's divisible by 1. So you can choose any one of the digits, whichever one you like, and it is divisible by 1. Okay, so 7 divisible by 1?
Yep.
Right. This time I want you to build on that number, so you're now going to make a 2-digit number, so you're going to add another number to it. That is divisible by 2. So the first digit has to be divisible by 1, and the 2 digits have to be divisible by 2.
Well, then I'll do 74.
Okay, so is 74 divisible by 2?
Yep.
Okay, how do you know?
Because it's got 2 even groups.
Can you explain more what you mean by that?
It can be split evenly into 2 different.
Great. Okay, now the challenge now, and this is where you might need those divisibility rules, the challenge now is to add an extra digit so the 3-digit number is now divisible by 3. So the first digit has to be divisible by 1, yes. The 2 digits here have to be divisible by 2. And when you add the 3rd digit, it has to be divisible by 3. So if you look at those divisibility rules, you might find there's an easy way of working out whether it's divisible by 3. Now you can't change them, you've already put them in the... So you've got first place, second, you're adding 1 here. So what does the divisibility by 3 say? What's the rules?
If the sum of the digits is divisible by 3, then the number is also divisible by 3.
Okay, so far, if you add those up, 7 and 4 is 11. Is that divisible by 3?
No.
What would you need to add to make it divisible by 3?
You'd need to add 1.
Or is there an alternative?
4.
Is there an alternative?
Yep, 7.
Okay. All right, so maybe if you find your 1, you've got your 1. Okay, so we know the first digit is divisible by 1, the 2 digits are divisible by 2, the 3 digits are divisible by 3, and now you've got to add a 4th digit, so the whole thing is divisible by 4.
Okay, well, I know that 7 and 4 already add up to 1, and I'm 11, and then if I add that, it adds up to 12, so I need to find something that's divisible by 4. And I know that...
So if you look at the divisibility rule, what's it saying that you need to...
If the last 2 digits form a number divisible by 4, then the number is also divisible by 4.
Alright.
So I've got to make it add up to 4, so I know that 1, you need 3 to make it 4, so...
Okay, so is there any way we could check whether 7,413 is divisible by 3?
Yeah, by using a calculator and
Fantastic.
dividing it by 4.
Yep. So you've actually used the rule though, which says you have to look at the last 2 digits.
Yep.
And if they're divisible by 4. Okay. Normally I would ask to say, it's, stop there, but the challenge would be, can you keep going? But I think you could probably go another step. So this time, first digit divisible by 1, first 2 digits divisible by 2, first 3 digits divisible by 3, and we had to make sure they added up to a number divisible by 3. We know this number is divisible by 4 because those 2 digits add up to a number divisible by 4.
Yep.
How would we recognise whether by adding a 5th number it would be divisible by 5?
Well, number divisible by 5 only really has 2 different ways, so it has to either end in 5 or 0.
Okay, so would you like to choose one?
Yes, I will choose 0.
Okay, so at the moment we have a 5-digit thing where the first one is divisible by 1, the first 2 are divisible by 2, the first 3 are divisible by 3, the first 4 are divisible by 4, the first 5 are divisible by 5. Oh, can we do the number 6? And the divisibility rule says...
If the number is divisible by both 3 and 2, it is also divisible by 6. So...
Do you have a number left in your hand that will allow you?
So if the number is divisible by both 3 and 2, so I could just do
Is that divisible by 3 and 2?
Oh yeah, no. Then I can use 6.
Fantastic, yay. So we've got a 6-digit number that's divisible by 6, and the challenge would be, can you keep going for 7 and 8 and 9 and 10? Okay, thank you. We will leave it there.